All right, welcome back to another geometry lesson. Today we're going to look at the review. I'm going to work through all the review problems. I'm also going to look at the valid list of reasons and kind of go through some of that for you. Okay, so if you haven't tried the review, I suggest that you go ahead and work on it a little bit and see what items you can get done on it, and then come back and check out the video. So, all right, here is our review. All right. Number one here says, what angles are congruent to angle 3 and y? So here's angle 3. Okay, the first one I'm going to go to is angle 2. So angle 2 is congruent to angle 3 because those are vertical angles. Okay. And then we'll go down here to angle 6. So angle 6 is congruent to angle 3. Those are alternate interior angles. And then the last one we have is angle 7. So 3 and 7. So angle 7 is congruent to angle 3, and those are corresponding. Okay. I could, pick a different number and say, what are the angles that are congruent to that new angle, or something like that. So be ready for any kind of angle and any kind of angle pair. Okay, number 2 comes with this picture down here. It says, which angles are corresponding? Now, there are multiple answers for this. So when I go through it, I'm only going to go through maybe 1 or 2 answers, but know that some other answers do exist. On the test, you may only have to pick one pair. So which angles are corresponding? So I'm going to go with 1 and 2. So 1 and 2, or I could do 3 and 6, or 5 and 8, 4 and 7, something like that. If you want more, you can look in your notes and see what we did for that day. So 5 and 8. Alternate interior. So they're on the inside, they're on opposite sides of the transversal. So you have 4 and 8, or 3 and 2. Alternate exterior. So on opposite sides on the outside. So you have 1 and 6, 5 and 7. Consecutive interior. So same side on the inside. That would be 4 and 2 and 3 and 8, which I'm not going to write down. Consecutive exterior. So on the outside of your 2 lines on the same side. So 1 and 7. Okay, you got a couple vertical angles. You actually got 4 options here. So we could go 1 and 3, 4 and 5, 2 and 6, 7 and 8. So I'll just write down a couple there. Again, you may not need to know them all, but there are multiple ones there. Okay, here you can see that I have these 2 lines that are parallel, and it says find the value for x. So if these lines are parallel, these are alternate interior angles, and they must be equal. So we're going to say 5x plus 25 equals 135. Okay, and we can solve for x by subtracting 25. So 5x equals 110. Divide by 5. And x equals 22. Okay, if you need a calculator, by all means, use one. Use Desmos, use something to help you out. Don't think that you have to do it all by memory. If you need an extra sheet of scrap paper, ask. Okay, so x is 22, and this angle is 135 degrees. We already know that because we said that they're equal. Okay, here's one, find x and y. Okay, I've got vertical angles right here with both x's, and these have an x and a y in it. So I don't want to compare those, I want to compare the x's. So we have 12x equals 10x plus 20, because we know vertical angles are always congruent. So subtract 10x, 2x equals 20, divide both sides by 2, and x is 10. Okay, so that's x. We could go ahead and find these angles. So 12 times 10 is 120, and this is also 120. Now to find a y, I use these two. These two end up on a straight line. So if I add them, 120 plus 3y plus 3, they have to equal 180 degrees. Okay, so I'm going to subtract 120. 3y plus 3 equals 60. Subtract 3. 3y equals 57. Divide both sides by 3, and y equals 19. So we got x and y there. Again, they may want you to plug it in. So 3 times 19 plus 3, this is 60, and this would be 60. And if you take 60 plus 60, you get 120 plus 120 plus another 120 is 360, which is your full circle. Okay. On this one, we're going to find the value of x. You notice down here I have a right angle. Okay, so if I add these together, 3x plus 15 plus 2x plus 5, I will get 90 degrees, a right angle. So 3x and 2x makes 5x. 15 and 5 makes 20. 90. Subtract 20. 5x equals 70. Divide by 5. And x equals 14. Again, if they ask you for the value of the angle, you just take that 14 and plug it in. So this is 3 times 14 plus 15. This is 2 times 14 plus 15. And you'd get out those numbers. Okay, find x. It says the measure of angle ADC is 85. ADC is the whole thing. So if I take the two parts, add them together, it will equal the 85. Okay, so 2x plus 3x is 5x again. Negative 3 minus 2 is negative 5 equals 85. So add 5. 5x equals 90. Divide both sides by 5. And x equals 18. Okay, so again, plug it in. 3 times 18 minus 2, or 2 times 18 minus 3 to get those individual angles, which that's not what it asks for. In this case, I'm just saying sometimes it may ask you for that. All right, flipping it over to the back. On the picture, mark a pair of, and then it gives you all these. So if I want to mark a pair of corresponding angles, I'm going to use A for that. So this angle and this angle. Okay, those are the ones I picked. There are 4 sets of corresponding angles here, so you may pick something different. A pair of consecutive interior angles. So B and B. Alternate interior angles. So I'm going to put a C here and a C here. So I'm talking about this angle. Some of your letters will double up, and that's okay. Vertical angles. So let's put a D here and a D here. So those are vertical angles. Alternate exterior angles. So alternate, so E and E. Okay, again, you could have different angles on there. This is just what I'm doing here. Number 8, what can be concluded from the picture? Okay, basically, what is this picture telling us? And I'm going to write it in geometric notation. So one thing is I see this 90-degree angle right here. So I'm going to say that CB segment is perpendicular to BE BA segment. The other thing, I have these congruent symbols here. So I'm going to say segment CB is congruent to BA. This is back from the first unit with some of this notation stuff. So make sure you know kind of the symbols on a picture and how to use their notation. Number 9, prove that angle 1 is congruent to angle 2. So this is kind of that angle hopping activity that we did. So here's angle 1. So I'm going to say angle 1 is congruent to angle 19 right here, because those are alternate interior angles. And the one thing I probably forgot to put on here is that all these lines are parallel to each other. Okay, so 19, and this is not the path that you have to take. This is just the path that I see. So 19 to 20, that's vertical. 20 to 16, those are corresponding. Okay. I might go from 16 to 13. Those are also corresponding. 13 to 14. Those are alternate interior. Okay, your goal is not to do corresponding the whole way through. You want to get a variety of angles. And then 14 to 2, those are vertical. So vertical angles. So angle 1 is congruent to angle 2 by the transitive property. Okay. So that's one way of proving that those angles are congruent. Okay, number 10 here, prove the following. And check your notes because we have done this before. So these are vertical angles 1 and 2, and I want to prove that they are congruent. And there's a lot of ways to prove that they are congruent. We could prove it by a transformation, like a rotation of 180 degrees, and they're the same, or a reflection across this dividing line here. But the main way that we want to look at proving that these two angles are congruent is saying that here 1 and 3, angle 1 and angle 3 are a linear pair. And also 2 and 3 are also a linear pair. Okay, well, if those two are a linear pair, then the measure of angle 1 plus the measure of angle 3 equals 180. And the measure of angle 2 plus the measure of angle 3 equals 180. Because they are a linear pair, they're supplementary angles. Okay, so we could say here, definition of a linear pair or definition of supplementary, something like that. So now these two both equal 180, so I can set these equal to each other. So the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. That was substitution. Okay, that's a substitution property. And we notice here we have angle 3 on each side. So if I subtract the measure of angle 3, I get the measure of angle 1 equals the measure of angle 2. That was the subtraction property of equality. And if I wanted to go, I could stop there, but if I wanted to go a step further, I could say angle 1 is congruent to angle 2. And you could say definition of congruence or definition of congruent. Okay. The last thing, you need to know this list of valid reasons and have it with you. Okay. So I'm going to go through some of these here just so you have an idea. So definition of an angle bisector: splits angle into two congruent parts. Segment bisector splits segment into two congruent parts. Definition of midpoint. A midpoint is kind of like an angle bisector, but a bisector can be different things other than a point. So a point that splits segment into two congruent parts. Definition of a right angle: 90 degrees. Definition of perpendicular: intersects at 90 degrees. Definition of congruent: same measure or they're equal. Definition of complementary angles: sum to 90 degrees. Definition of supplementary: sum to 180 degrees. Definition of adjacent angles: share vertex and side. Doesn't overlap. Definition of parallel lines: same plane, same distance apart. Okay, all that stuff's old Unit 1 stuff. So this stuff here is from algebra. So the addition property is add on same side. And then subtraction, multiplication, division properties all very similar. You're going to subtract on the same side. You're going to multiply on the same side. You're going to divide on the same side. Addition property of equality. Anytime it says of equality, you're doing it to both sides of your equation. So add on both sides. Okay, subtract on both sides, multiply on both sides, divide on both sides. Okay, for these, we're going to kind of write something a little differently. For distributive property, we'll just write an example. So the distributive property removes parentheses. Okay, so if you got A parenthesis B plus C, that'd be AB plus AC. You can distribute that in there. Substitution property, plugging values in that are equal. Transitive property, that's the linking one that we talked about. If A equals B and B equals C, then A equals C as well. And this could go on a very long time. Symmetric property, if A equals B, then B equals C. Okay, symmetric, it's the same backwards and forwards. Reflexive property, if, well, that's just saying that A equals A. The same thing is congruent to the same thing. And we'll use that a lot when we get to triangles and things that are shared among two shapes. Okay, so reflexive is just like you looking in the mirror, you see yourself. It's the same thing. Angle addition property and segment addition property we've used before. So add parts of angles to get a bigger angle. Segment is add parts of segments to get a bigger segment. Translation is a slide. Rotation is a turn. Reflection is a flip. Vertical angles are congruent. So we're just going to leave that one. Some of these we're not going to deal with right now. We'll deal with kind of later, or we won't deal with them at all. So I'm just kind of scanning through here and seeing what we got here. Okay, down here, alternate, if parallel, alternate interior angles are congruent. So you might write, if parallel, alternate interior angles are congruent. Then if you flip it over here, it's if parallel, alternate exterior angles are congruent. If parallel, corresponding angles are congruent. If parallel, consecutive interior or exterior angles are supplementary. Okay. And these are the converses. Converse just means the other way around. So corresponding angle converse. So that means if corresponding angles are congruent, corresponding angles congruent, then parallel lines. If alternate interior angles congruent, then parallel lines. Okay, so that's the same for this one, consecutive interior, consecutive interior angles sum to 180, then parallel. Okay. And then we will get to some of these other things later on down the road. The extras that we have is first reason is given. Literally, it's the word given, okay? So hopefully that will help you. Again, I'll let you use this on the test and the retest and all that kind of stuff. So make sure you have studied that. Thanks for watching. If you got questions, please let me know.